Hi, everyone. My name is Nikol Grachevsky. I'm a software engineer at Grafana Labs working on Grafana Bela, which you're going to hear about in a sec.
I'm Matthew Durham, and I'm also at Grafana Labs and an Alloy developer.
Hi, I'm Carrie Edwards. I'm also a software engineer at Grafana Labs, and I work on migration tooling and OpenTelemetry and Prometheus.
All right, so let's get started. Now, this is a QR code for Slido. If anybody wants to ask any questions in the QA session, I promise it's not a Bitcoin or miner virus that will steal your phone's resources. No, it's for QA at the end. All right, so there's a couple of things we're going to talk about today. Most importantly, we're going to talk about OpenTelemetry and how we at Grafana are building on top of it. We're going to talk about something new, which is a single command line that will get you from 0 to 1 with OpenTelemetry for any programming language. We're going to talk about how you can easily migrate across vendors with OpenTelemetry. And finally, we're going to show you how to manage all that scale. It's a big thing, but let's see. All right, so anybody old enough to remember this story, like from the late 90s and the early 2000s where we had these connectors, and I still remember I had a box of these jumbled wires and trying to pick the right charger for my devices. Well, not anymore. I think we have something like this, and this thing, this USB-C, charges my headphones, charges my earbuds, my phone, my laptop, and even my printer, which is kind of cool, right? Well, this is where we are today with our vendor lock-in. We have all these competing standards, and it's not easy to move across vendors or to even get the same telemetry data across. And we believe this is OpenTelemetry. We're going to get away from that mess that we had 20 years ago with the phone chargers. We're going to get to something really slick. All right, so OpenTelemetry in Grafana, we're all about this. We love this because, I'll be honest, we don't have another sort of proprietary mode. We're new to this, and we're lucky that we started doing this when OpenTelemetry became a thing. So this means no vendor lock-in if we manage to pull it off. And then it will be easy to extend your telemetry collection with new signals just like that. Standards are there. Easily swap out products, swap out vendors. It's a great future. And we believe we've built some really good products based on OpenTelemetry for application observability. And some of those you saw in the keynote presentation. By the first one, we already have in Grafana Cloud, which is Grafana Cloud Application Observability. A single pane of glass that gives you an insight into what your service looks like, their health, its pre-built dashboards, the stuff you need to kind of quickly have an overview into your service health. And then we have Grafana Cloud Asserts, which they have a presentation right after us. I don't want to steal their thunder, but this tool lets you go really deep with debugging production issue. It's really awesome. Okay, so now we got these tools. The main question, the one that this talk is about, is how do we get started? How do we get these applications to work for us? We've built them. They're ready to accept this OpenTelemetry. And there's a couple of things we need to do. So we need to instrument our application. Okay, so what does that actually mean? The answer is depends. Depends on what you have in your application cluster. It could be as easy as putting auto instrumentation on with a jar for Java. Or it could be difficult because your frameworks you're using or the application technology that's built with is not supported. Or it's a couple years behind and it needs to be upgraded and so on. This becomes a problem sometimes. And it means that just like everything else in life, it will require some learning, some effort, some time, which will compete with your existing timeline for building the product you're building, which serves your customers instead of telemetry, right? So does this mean we actually created a new headache for everyone by creating this brand new standard now everybody's going to migrate to, and it's going to be slow and so on? So we like to change this outcome. We like to make OpenTelemetry available to everyone, because we really believe in this. Like, I don't know how many of you are actually developers, but of those of you that may have done Java application development with SQL in the past, where before JDBC, it was a nightmare because as soon as you got all the dependencies in your code with the vendor-specific SQL database, and changing databases is tough luck. But with introduction of JDBC, this is no longer a problem. So same thing will happen with telemetry. Introduction of OpenTelemetry, we have a standardized way how we operate with telemetry. So I want to ask you, what if we could give you a way to get started with OpenTelemetry with zero effort? You don't even have to know what it is. And it also means that what if you could just extend that further with everything that is OpenTelemetry in the community without having to do jump right into it. You can take your time and slowly add instrumentation for the stuff you need more instrumentation, like business logic, anything else. So today, we're going to talk about a couple of tools that we've built to do just this. All right? So I'm going to hand over to my colleague Matt here, who's going to talk about the first.
Thank you. All right. I want to talk about Grafana Alloy. Now, if you're unfamiliar with Grafana Alloy, it is our distribution of the OpenTelemetry collector. And it is the foundation of everything we're going to talk about today in this session. So when we talk about Big Tent, we mean that that integrates with the community. And Alloy is built on that it integrates with Prometheus. And it also integrates with Prometheus, or OpenTelemetry. And we announced it back in April, and it's gotten some drive. And to take a step back, you may remember Grafana Agent, which was a very Prometheus-oriented solution. And when we wanted to look at where we wanted to take the agent, we saw a rise of OpenTelemetry. But we also found that people were using both. They were using OpenTelemetry in their application metrics, but using Prometheus for generally their infrastructure. So we built Alloy to combine the two into one. Now, I don't have a lot of time to talk about all the features of Alloy, but we have great native Kubernetes support. We have scaling from pulling data from a single node to running in a clustered environment, programmable pipelines, and we have answers for configuration management, which we'll talk about just a little bit later. All right, and I'll turn it back over to you.
All right, thank you. All right, so that was pretty cool. And how does that actually go back to this single command line? That's something I'm talking about, instrument everything, no effort whatsoever. We introduced the easy instrumentation button. As Alloy is a platform in which we can build components, we took Grafana Bela, which was something we announced last year at ObservabilityCon. It's a brand new product then. It's evolved quite a bit since. But for those that don't know what Bela is, it's a really low overhead auto instrumentation tool built with eBPF as a technology, which means it works at the operating system level, Linux only, until Windows catches up. But technically, it supports instrumenting any programming language. And I'll tell you, we have customers that use this OSS product with R. I did not know that R has a REST library that you can build web services with R. I thought it was a language for data science. But apparently people do this in R. And so if your application does speak the protocol of the internet, like HTTP, HTTP2, gRPC, SQL, Redis, Kafka, we are able to pull instrumentation data, tie it together, and provide the signals, metrics and traces to limit and support. It's a Kubernetes and container aware. And so let's just, I'll stop talking here. Let's see a demo and see if actually I'm making this up or not. All right, first demo, please. Okay, so what we're going to do here is we're going to get a Kubernetes cluster going from scratch. This is running on my laptop, by the way. Everything you're going to see here is pre-recorded because some of these images are going to take a while to download. So what we're going to do here, we're going to install in this cluster a suite of applications. They're built by the OpenTelemetry demo community. They actually have a full website for e-commerce built with microservices architecture. It uses, on purpose, a large number of different technologies to accomplish this thing. And what we've done in this particular demo, we've stripped it of all telemetry. All the hard work these people have done, we've taken it all out. And over here, I'm showing you with this K9s cluster that is going to, here, I'm just going to disable all the observability components. Just to be honest here, there's no telemetry data escaping this cluster whatsoever. So we're going to kill the OpenTelemetry collector, Prometheus, Jaeger, Grafana, all gone. Nothing. This is a dark cluster. We have nothing. We don't have no knowledge what it does, what technology is actually this service is built in. We know there's some load generator here, pretends to generate web traffic. Okay, we have an application set going. So what we want to do here is now use this zero effort instrumentation tool to see if we can get the data out. That's what we're going to do. So we're going to get this cluster, and we're going to add instrumentation to it. But for all these services, we don't even know what technology they are. To do that, we're going to use the Kubernetes infrastructure monitoring. They've actually recently added support for application observability. So we're going to use their integration tile on the web to actually not have to even type Helm commands. So we're going to pick a Kubernetes cluster, which this already is pre-selected for me. I'm going to enable application observability. We're using Helm here. Here, I'm going to pick a key that I've created for Grafana Cloud for easy integration. And it gives me this nice little script here that I can just copy paste into my terminal and get going. This is my single command line, instrument everything in my cluster. So what people that are familiar with Kubernetes monitoring Grafana Cloud know that this does infrastructure monitoring. But now at the end, I've injected this additional Bela section, which enables it and gives us a little bit of introduction that you can configure it to your heart's content here. And in this case, what we've chosen here to do is we're going to instrument everything. Kubernetes deployment name dot means all. We're going to say we don't want to instrument Alloy because it's our actually collector. And I've enabled something called network monitoring. I'm going to get to that in a second, but let's just remember here that I'm enabling network monitoring too. All right, so this does this thing, installs a bunch of components. As you can see, my cursor is sped up here, so we don't wait. And let's see what happened to a cluster. All right, so supposedly this command ran. It should have instrumented, added something. So what we see here is the typical Kubernetes monitoring that we have today for infrastructure monitoring components. But if we switch to the daemon set section, we're going to see there's a component called Grafana Bela here installed. All right, this is the tool that is monitoring this at application level, doing application level signal telemetry instrumentation. All right, we got something going. What happened? Let's go back to our Grafana cloud and see what happened with that command line. All right, so first thing we're going to do, we're going to see if data is coming through. Can I see my cluster in infrastructure monitoring? OK, yeah, it seems like I got one here. And yeah, some charts are popping up. It's running for the last 5 minutes, so there's really not much data to look at. So yeah, we got CPU. They knows that I have 20 cores on my system, and I've got a bunch of memory and CPU utilization happening. Cost data takes about 5 minutes to show up. But here we have all the pods. You can jump into logs here, all the good infrastructure monitoring stuff. But that's not all anymore. If we switch to application monitor on the side, now I see all my services. Now, when I first did this, I see core DNS in there, and you're wondering, what the hell is that? Well, that's part of a Kubernetes. We said instrument everything. I didn't know that core DNS actually had a REST endpoint, but it's an application written in Go, and it does have a health endpoint, so Bela tracks it. We see all these services built with different technologies, all instrumented, and we have charts populated. We're tracking requests per second. We know latencies. We know everything. Now, let's see, there's a second page here. We can see we detect the language too. So this tool does instrument deeper certain languages it does recognize better. So we see there's some applications in PHP, some Go, Rust, all different technologies. We see all the data. We didn't have to build any of these dashboards. It just showed up. That's where we say zero effort, one single command. Let's dig deep into one of these services. So I'm going to pick on this checkout service, and we see I artificially actually made it slower to show for the demo there's a spike in latency. Can we debug this to some level here on the spot with this data we've collected? And mind you, I'm only collecting here metrics data. There's no traces. It's purely metrics. You can enable tracing if you want. For this demo, it's purely just metrics. We see that this has P99 latency increase, but also average, so something's going on with this service. But on the right side, we see there's no request per second increase. So something is slowing down the service. Can we find out? If we scroll down to the bottom of the page, we see we've detected that this service has only one endpoint, one REST API. But on the right side, you see that it does have a lot of other downstream services it calls. So maybe the problem is with our service, maybe it's one of the downstream services, what we can do. We see we're impacting that front end with 10-second P95. All right, so with the same data we collected over here, not only we see REST endpoints, but we're going to see a service graph. This also gets populated. So if we switch to the service map for this service, we see a distribution also show up. And we see how much of the latencies for some of these services contribute to the overall 500 milliseconds on average. With quick kind of like spotting here, maybe we can notice that is likely the shipping service contributing to that slowness over here based on the connectivity graph. The rest of the services are doing pretty well compared to that, right? Again, pre-populated, zero effort to get to this point. I didn't have to do anything. I don't even know what OpenTelemetry is. This is all backed by OpenTelemetry, ingested by our tooling. But this is not all. You remember I mentioned something about network observability? With this same command, with network observability, we enable Grafana Cloud Asserts. The thing you saw in the keynote presentation, we have a full connectivity graph. This is done collecting data about connectivity between services. People use this to debug if a service is actually really disconnected from their system or cross-region traffic. This actually can capture data regardless of the protocol. And we can open our service here and see what kind of data we can get deeper information, right? So last 5 minutes, I got to select my time window here. But you can see how I can correlate now the network flow in and out of the service and see if maybe that is the reason why my latency is higher, because I'm delivering more traffic. And I can correlate that with the request per second happening here and how the latency works. Now, this tracks also UDP. If you have DNS problem, it will show up here. So again, doesn't actually have to be an HTTP service. And finally, over here, we can have the breakdown of the APIs, upstream and downstream, and you can clearly see the shipping service is causing a problem here. That's it, folks. This is for the demo. How cool is this? Single command, everything. And I want to show you a quote of our customer that's actually doing this in their setup. Various technologies, gRPC, HTTP, it all works with one single installation of Grafana Bela, and together in this presentation was bundled with Grafana Alloy. So, having said this, showing you how to get started from 0 to 1, I want to talk about how do we switch. And for that, I'm going to hand over the clicker to my colleague, Carrie, who's going to walk us through that.
Thank you. So migrations and reinstrumentation can be complex, challenging, and time-consuming. And as part of OpenTelemetry's commitment to vendor neutrality, the OpenTelemetry collector offers a series of exporters, processors, and receivers to get telemetry data into and out of OpenTelemetry format. And currently, the OpenTelemetry collector has support for many different telemetry data formats. But today, I'm going to highlight a new component that we developed in order to make migrations from Datadog easier and faster, which is the OpenTelemetry Datadog receiver for metrics, which integrates with Alloy. The story behind this project is that we had a large customer who wanted to make the switch from Datadog to OpenTelemetry and use Grafana Cloud as a backend. But they had a very complex ecosystem and knew that reinstrumentation would take some time. And in the meantime, they wanted to be able to continue to use the Datadog agent to send data while they went through the process of reinstrumentation. At the time, there was a Datadog receiver in the OpenTelemetry collector, but it only offered support for traces data and not metrics data. So we decided to build this and open source it so that the rest of the community can use it as well. So if you have applications such as this one that are instrumented with Datadog, you can use the Datadog receiver and continue to use your applications and have data sent to Grafana Cloud or any other OpenTelemetry compatible backend without having to make changes to your application code. We still recommend reinstrumentation for the long-term solution, but this can help get you started faster. Getting started with this tool is easy with Alloy. You can continue running the Datadog agent and forward your metrics to Alloy. The Datadog receiver will translate your Datadog metrics into the OpenTelemetry format. And then if you're sending the data to Grafana Cloud or a Prometheus-based backend, you'll want to use the delta to cumulative processor to get the metrics into the correct temporality before sending it to the backend. All this takes is a couple of small configuration changes. You just need to configure the Datadog agent to forward metrics to Alloy, and then configure Alloy to run the Datadog receiver, the delta to cumulative processor, and the OTel HTTP exporter. And just like that, you can visualize your Datadog metrics in Grafana dashboards. And now I'm going to turn it over to Matt to talk about how to manage all of this.
Thank you. All right, so we've talked about how you can instrument your applications without touching them, and how easy it is to switch from some other vendor to us. But that generally only solves half of the problem. You've probably got configuration that needs to enrich or transform or filter out data as it's coming through, some sort of telemetry. Now, that's hard to manage at scale, because you could have configurations across tens or hundreds of thousands of instances. And that can be baked in when you're building a virtual machine or deploying, and that's hard. And it doesn't support if you're a large organization that has observability as a service internally. And this is a lot of workflow that's painful for our users. So we took a step back, and we said, what can we do to make it better? So one thing I'm really excited to announce is we're having a public preview of what we're calling Grafana Alloy Fleet Management. And this is a tool built within Grafana Cloud that allows you to manage your Alloy instances at scale with custom configurations. So rather than reading all through this, let's take a look at what that actually looks like. So we have here the single pane of glass that kind of gives you the viewpoint. We can see we have our collectors on the left. We have some status, the version of Alloy that is running, the operating system, and then we have custom attributes. And this is what really lets you narrow down configuration to what you need by maybe team or purpose or environment, dev versus prod. You can also see the health of a collector, click on it, and get instant feedback. Metrics, logs, alerts. You can even dig into the alert, maybe click on a run book if you wanted there, and really be able to see what's going on with the health of your fleet. Now here you can see we're just digging around a little bit, kicking around. And then this is where the configuration screen is. So we have some configurations here. You can see what they apply to based on those attributes that you can set up, plus some like operating system. This active flag that you may create a configuration, but you don't necessarily want to release it right away, or you want to be able to roll it back. So toggling that on or off can control that behavior. Now, let's say we wanted to create a configuration. We're going to make a Bela configuration here. I've conveniently got it ready to copy and paste. You notice that it gives me an error at the bottom, and this is because there's a slight syntax error. So we have some guardrails to help you write good configurations and not deploy things that will just immediately fail. And then you can see in real time what collectors this configuration is going to apply to based on those attributes that you have defined and given. So, we only want this to run on Linux, and we want to run it on Team A. So you can see in real time exactly how that is going to roll out. So we're going to save that. And then we're going to click to send it out. So within minutes, all the Alloy instances will check for a new configuration and pull it back down. And then if you decide there's a problem, you can simply deactivate that toggle, and it will roll back the change. All right. To finish this up, Nicola.
Thank you. All right, so before we recap our presentation, to give you an opportunity to ask the questions one more time. But just to confirm what we talked about today, we showed you a future we believe in with OpenTelemetry, and we're building tools on top of it. We showed you how you can get there, get started without any effort from 0 to 1, and then on top of that, you can extend at your own pace with OpenTelemetry using the community build SDKs supported by Grafana and others in the community. We showed you how we can easily migrate from different vendors by giving you an insight into how we actually build a Datadog receiver for OpenTelemetry, and finally, how you soon be able to manage all this at scale with Grafana Alloy Fleet Management. Thank you. That's it.